So this is a hard question because it's easy to overlook certain cases, especially when you're under time pressure. So this question, we're told that 120 can be written as product of different integers, for example, 3 times 4 times 10. They're looking for cases where they are, the factors are consecutive integers in ascending order. Here they are in ascending order, but they are not consecutive integers. The other clue is that they're including -1, which means you can have 1 also as a factor. So 120, some of you might know, is same as 5 factorial. So that might give you a clue that, hey, this example works. 1 times 2 times 3 times 4 times 5. What about with the negatives? Well, if they're all negatives, the product is actually minus 120, so that doesn't work with negative. We can't make 4 of them because then they would no longer be consecutive. So that's the only case so far. The other thing I also did was to look at the prime factorization. And I think at this point you certainly see 2, 3, 4, 5, or you also kind of see that here. So that works. But I can also do -5, -4, -3, -2. In this case, because I have an even number of terms, this product is still positive, 120. So I have 1 example, 2, and then 3rd. I think the 4th one is probably where you have to, I think that's what makes this problem difficult, is that you have to be sort of actively looking for it, because you could stop at this point and say, hey, there are 3 of them. But you have to sort of explore, and I think the link for me was that that's 6. So 4 times 5 times 6 is another case. The negatives won't work. I can see some students saying that also works, but this is actually minus 120. Just as was the case here, the -1, the minus corresponding example doesn't work because that's minus 120. And that's why 6, which I think is probably the trap here, we have actually 4 cases. And they are the ones here that I've circled. And that means the answer is 4, which is choice C.